number 12. Okay, I'm going to do it slowly so that you can understand, alright? Now let's take a look. Show that now, I want to know first part. Is it cannot do? Or can do first part, cannot do second part? First part, who cannot do? Okay. Show that this one differentiate, get this one right. You must show. It's a very kind question, or why? Because even if you don't know this, you don't bother use also can. So let's differentiate this. D over dx, x squared over this. Okay. Now I differentiate this. This is quotient rule. I square the bottom right. So become what? Right now. Then I fix the bottom. I differentiate the top, become what? 2x. Very good. Minus what? Fix the top. Then I differentiate the bottom. Now don't forget, the bottom is actually 4x minus 5 half. So when I differentiate the bottom, it becomes what? Half 4x minus 5 power negative half times 4, right? Can you see it? Chain rule, okay? Alright, so this is the whole thing here. So let us take a look. How did it ever become that, right? So let's slowly do don't panic first. This is 2x square root 4x minus 5 minus 2x squared. Then this is a 1 over square root 4x minus 5 over 4x minus 5, right? Okay? Now, I teach you before, right? In order to get rid of the square root 4x minus 5, I times top and bottom by 4x minus 5, square root 4x minus 5. I multiply by 1, I can get rid of it. So this one becomes 2x, then 4x minus 5, right? Minus 2x squared, because the 4x minus 5 will cancel off, over 4x minus 5. Now this is power 1, right? And then I multiply by square root of it, so it will be a 3 over 2, am I right? Correct now. So let's expand this out. 8x squared minus 10x minus 2x squared. 4x minus 5, 3 over 2. 6x squared minus 10x over 4x minus 5, 3 over 2. So this is shown. Okay, 0. If you still can't do this, that means something is wrong with your differentiation. Do you understand? Do you understand what I'm saying? Because this is a very simple one already. Square the bottom and then blah, 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 that kind of thing. Okay? So, show. So I have already shown. Alright? Now, next. Hence or otherwise, find this part 2. I'm supposed to integrate now, they are somewhat the same but not the same. Agree or not? I told you already yesterday. We can only add in what? Constant, right? We can only add in constant. So, do you agree that if I integrate this guy, then I can get this guy? Everybody clear? Everybody clear? Okay, now all of you look, wait, how do I get back to this guy? I must times what? I must times 2, right? So, when I times 2, I must divide by half, right? I mean, I must times half, right, outside. So that it will become the original, remember? It must become the original. And see, I'm not doing anything stupid or whatever. I'm actually multiplying by 1. Half times 2 is actually 1, right? So, this one will become half integrate like that, right? Can you see, I've rewritten it to something I know. So, when I integrate this, what do I get? I get this one. Okay, so it will be half times x squared over square root 4x minus 5, then plus c. Everybody okay? So, of course, this one, if you want to straight away simplify, it will over 2 square root 4x minus 5 plus c. Actually, this one shouldn't have a problem. It's this part you don't know how to write, then got problem. The first part shouldn't have problem one. Everybody okay with number 12 part 1? Yes, I mean number 12 part 1. Number 12, okay? Can understand, huh? Can understand, huh? Now, you must always do this, huh? Understand, huh? Write the original one, then see how I can do to the next one, but I must keep the original. Clear or not? I always present this way, okay? Alright, so that will complete your number 12. Next is your number 14. Okay, let's look at number 14. Given that d2y dx squared is 2x minus 1 and that dy dx is 6 when x is 2, find the increase in y when x increases from 2 to 3. Okay? Alright, this is, what question is that? Question number 14. Okay? So let's take a look first. Alright, I have d2y dx squared as 2x minus 1. Right. Can someone tell me how do I get dy dx? I must integrate x minus 1, right? Correct. So this will give me what? 2x squared over 2 minus x plus c. Right? So this will be a x squared minus x plus c. Correct now? Am I right? Now the question say what? dy dx is 6 when x is what? 2. What do you think they want us to find? They want us to find c, correct? So we will have 6 equals to 4 minus 2 plus c. C will be equals to 4. Can you see it now? That means after this step, I would have known that your dy dx is actually x squared minus x plus 4. Okay, this one is not I write one, your dot is this figure. Don't go and put a dot down there, I tell you first. You understand what I'm saying? Okay? Okay. Then, what do you think I should find next? Y, right? Okay. dy dx is this. So y will you integrate this one, right? Which will be integration of this dx. X cubed over 3 minus x squared over 2 plus 4x. Now I must plus d, right? You don't use c again because c you already use already, so you use d. Okay? So y will be equals to x cubed over 3 minus x squared over 2 plus 4x plus d. Can not? Okay, you say, Cher, I cannot find d, right? No worry first. D is just a constant, okay? What did the question say? Can you read again? Find the increase in y when x increases from 2 to 3. Okay, I'm going to do down here. When x is 2, y is 8 over 3 minus 2 plus 8 plus d. This will give me 8 2/3 plus d, right? I just sub in. Correct now. How about when x is 3? Y will be 27 over 3 minus 9 over 2 plus 12 plus d. This will be a 16.5 plus d, right? Correct. Now what did the question ask? Can you tell me? The increase in what? Y, right? Increase in y is what? This one minus this one, right? Can you see when I take this one minus this one, the d will be cancelled off straight away. Okay, so increase in y. So this will just give you 7/5 over 6. that clear? Now, some people is very smart. They say, oh, got D, I purposely don't write, but I still get the same answer. Okay, that's wrong, conceptually wrong. You understand what I'm talking about? It's because the D and D minus off, that's why you don't have the D. It's not the D don't exist. You understand? Because every time I do this kind of thing, the exam comes and say, my answer is correct, why you mark me wrong? Your concept is totally wrong. Understand? Okay? So 12 and 14 done already. Are we clear? Are we clear, class? Next, I'm left with 3 more questions. Okay, next, let's look at 15. Question 15. Are we okay? Are we okay? Alright, question 15. At any point on a curve y equals to mx, d2y dx squared is 1 minus x squared. The equation of the tangent to the curve at the point 1, 4 is y equals to 5 minus x. Find the equation of the curve. Okay. Now, class, if they want to find the equation of the curve, that means they are finding y, right? Alright, okay. So don't worry first, you slowly do, okay? Now, d2y dx squared is 1 minus x squared. How would I find dy dx? You should know, right? How to find dy dx? Tell me now. Integrate what? 1 minus x squared must never put dx. Okay? So this will be x minus x3 over 3 plus c. Correct? Yes or no? Now, they say that the equation of the tangent, okay, hello. The equation of the tangent at this point is this one. That means this is like this, right? That means when x is 1, what is my gradient? Negative 1, right? Can you see it? Equation of the tangent means the gradient of the tangent at the particular point must be the dy dx, right? Agree, class? So, when x is 1, dy dx must be negative 1. Can you see? Because of this gradient. Alright, now you have a curve. At this point 1, 4, the equation of this tangent is y equals to minus x plus 5. Of course, it's wrong, it should be the other way. You understand? I just show you first. Can you see that the gradient here is negative 1? So the dy dx must be negative 1, right? It cannot be, must show you like that, then you can see. This one is invert. You understand what I'm talking about? Okay? Alright. Now, so if this is the case, right? What will happen is that negative 1 will be equals to 1 minus 1/3 plus c. Okay? So, c will be equals to negative 5 over 3. Is this correct? Is this correct? I'm talking to you. Yes, Okay. So, we know dy dx is x minus, now this is the same as 1/3 x cubed, then minus 5 over 3, right? My aim is to find what? Y. So I integrate this guy again, right? So y will be the integration of this. Agree, class? Which means it will be x squared over 2 minus 1/3 x4 over 4, right? Okay? Minus 5 over 3x plus d lah. Now I'm going to simplify further first. Minus, this is x4 over 12, right? Minus 5 over 3x plus d, right? You can say 5x over 3 also can, doesn't matter. Now some people will be stuck here. They don't know what to plug in. Do you agree that this point is on the curve? That means this point is very quite useful, right? You can use it for dy dx, you can also use it for y. You understand what I'm talking about? So when x is 1, what is my y? 4, right? Okay? Alright. Half minus 1 over 12 minus 5 over 3 plus d. You will get your d as 21 over 4, correct? So your y is straight away half x squared minus 1 over 12 x4 minus 5 over 3x plus 21 over 4. Everybody can? Now, why did I choose this question? It's not that I choose the question. It's because I want you to know this point, this gradient, okay, and that point can be substituted here again. Because some people, they just look, wow, Tom, die straight away. Cannot. Even if my diagram is wrong, can you see it's still useful? Why is my diagram wrong? Negative x. That means it's negative 1, right? Actually, the curve, it should be like that, right? A negative 1. Everybody clear? But I told you already, diagram is just symbolic, like circle property. I mean, the image of the circle, just say anyhow draw can. As long as you can picture it can already. Everybody clear? Okay, so that is your 15. Next, we move on to 17. Okay? Let's move on to 17. The curve is such that d2y dx squared is 6x plus 3. And the gradient of the curve at 2, negative 60 is negative 18. That means at this point dy dx is negative 18. Okay? Find the coordinates of the stationary points of the curve and determine the nature of these stationary points. Now what are stationary points? What is 0? dy dx is 0. Okay, good. Let's take a look here. When I want to find dy dx, I must integrate this guy. So this one becomes what? 6x squared over 2 plus 3x plus c, right? Okay, this will give me what? 3x squared plus 3x plus c, right? Everybody okay? Now, you realize that when x is 2, dy dx is negative 18. The question say one, I thought I say one. Okay? So, negative 18 will be 3 into 2 squared plus 3, 2 plus c, right? Alright. So, you will get your c as negative 36. Okay? So, your dy dx will be 3x squared plus 3x minus 36. Everybody okay? Everybody okay? Now, after I reach this step, right, what do I do? They say what? What did the question ask for? Stationary points, right? Stationary points will be when dy dx is equals to 0. So, when dy dx is 0, I will have this guy equals to 0, right? So I will have 3x squared plus 3x minus 26 equals to 0. I can divide 12 by 3 first, right? Okay. X squared plus x minus 12 equals to 0. I will have a x plus 4, x minus 3 equals to 0. So x is negative 4, or x is 3. Everybody okay? Everybody okay? Okay, now. Like that, I still cannot get the stationary point because I cannot find the y coordinate. Agree, class? How would I get the y coordinate? I must get the equation of the curve first. So I must still integrate this guy. Am I right? So how do I get y? Am I right? Yes or no? then I want to ask a question. How would I find D? Sub in what? 2 and negative 60, right? Just now that method, correct? So I will have negative 60 equals to 8 plus 6 minus 72 plus D. You will get D as negative 2. Will you get that? Okay, so the equation is y equals to x cubed plus 3 over 2x squared minus 36x minus 2. Okay, now I'm going to get the coordinates already. Okay, of the stationary points. When x is negative 4, y is 102, right? So when x is 3, what is your y? Negative 69.5, right? Or negative 69 and a half. You can give it informal fraction also, okay? Doesn't matter. Can or cannot? Okay, now plus. This is the point, Correct? Now plus the question already have d2y dx squared is 6x plus 3. Don't go and differentiate again, you understand? They already give you that, don't go and differentiate again. Understand? So at negative 4, 102, d2y dx squared is 6 into minus 4 plus 3. So this is a less than 0. Okay, less than 0. Wow. That means what? Less than 0 means this point is what? Negative 4, 102 is a maximum point. Okay, now at 3, negative 69.5, d2y dx squared will be 6 into 3 plus 3. Now this is positive. So 3, negative 69.5 is a minimum point. Now I need to warn you about your presentation because your WA is coming. When its coordinate is maximum minimum point, when it's like maximum minimum, that is maximum value, minimum value. It's not a point. It's like the area is maximum, the surface area is minimum, that kind of thing. Okay, don't everything go by point, understand? Okay, so 17 is done. Are we clear? Are we clear? Now, can you see it's very tedious? But the thing is that if you follow the concept, you will not be wrong. Everybody clear so far? Okay. Next question. The last one, right? 18, right? Is it correct? Correct. Okay, let's look at 18. Okay, let's look at 18 now. The gradient of a curve is kx plus c. That means kx plus c is actually dy dx. Can you see that? Okay, where k and c are constants. The curve has a stationary point at 2 minus 3. What do you mean by that? That means dy dx 0 at 2, negative 3. Okay, and intersects the y-axis at 0, 1. Okay, y-axis means x equals to 0. Okay, find the equation of the curve and the equation of the tangent to the curve at 0, 1. Okay. First of all, I don't understand this thing keep falling. That means this gradient has increased again. And in fact, that is not my pen. Just trying to make me fall down. So I will throw this away. Here. Okay, number 18. We know that dy dx is kx plus c, right? Okay, now what else do we know from the question? We know that dy dx is 0 when x is 2, right? Correct. And then when x is 0, y is 1, right? This is the information given by the question. Can you see? I always write down the information given by the question. Okay, now all of you look at that. don't go and plus C again. How long you all must see popping again? Plus what? D. Okay, good. Now, how? You know that it passed through this point. 0, 1. So 1 will be D, right? Correct? Because it's passed through 0, 1 ma. When x is 0, y is 1 ma. So D is 1. So I will get the curve as kx squared over 2 plus cx plus 1. Agree or not? Yes or no? Yes or no? Then my point is to find what now? Already found out D. My point is to find out what? Can find C already? Can you see that we can find C? Okay, all of you look dy dx is 0 when x is 2, right? The question says what? So 0 will be 2k plus C, right? Okay? So after this, how? Make C the subject. How to make C the subject? Look at the question again. What did they say? The curve has a stationary point at 2, -3. If the curve has a stationary point at 2, -3, that means the curve must pass through 2, -3, right? Just that this 2, -3 can be a maximum or a minimum point. So, when x is 2, y is -3, agree? Correct. Okay, repeat. The curve has a stationary point at 2, -3. So it can be here or it can be here, right? And the curve must pass through this point. Agree? The stationary point must pass, the curve must pass through the stationary point. So how can it be maximum or minimum point? Okay, so I plug in to here. So what do we have? -3 equals to, I plug in 2, so it's 4, so 2k plus 2c plus 1, right? Am I right now? So this one will give me what? 2k plus 2c equals to -4. So k plus c is actually -2, right? Agree? Now I have two equations, two unknowns already. Some people say, wow, so where's the equation? No? I have 2k plus c equals to 0. And k plus c equals to -2. Can you see? This one and this one. I will solve simultaneous equation, right? Now let's call this equation 1, equation 2. Oh, okay, I minus off. So I take equation 1 minus equation 2, I'll get k equals to 2, right? Okay? So when k equals to 2, c will be -2 minus 2. C will be -4. Agree now? So what is the question asking for? First part, the equation of the curve. Now the equation of the curve is this one. I already found my k and my c. So equation of curve. Y equals to 2x squared over 2 minus 4x plus 1. So this is x squared minus 4x plus 1. Everybody okay? Everybody okay? Can see or not? Can see or not? Okay, then what's the next part? What's the second part? Find the equation of the tangent to the curve at 0, 1. Now, this is part 2. That means dy dx will be k is 2, so it's 2x minus 4, right? dy dx is 2x minus 4, right? So, at 0, 1, dy dx will be a -4, correct? Okay, so equation of tangent will be y minus 1 equals to -4x minus 0, okay? Correct now? Y minus y coordinate, gradient x minus x coordinate. So y equals to -4x plus 1. That will be the equation of the gradient, of the tangent, sorry. Everybody okay? Now what if I change to the equation of the normal, then how? What if and one equation of the normal. And what's the gradient? 1/4. Understand or not? 1/4. So must be able to flip like that. Then you can get the answer. Everybody clear? Everybody clear? Okay, so I finished 16.1. Okay? Alright. When you're done, can you pass forward your 16.1? I'm going on to the simple type of 16.2 first. Okay, 16.2 is integration of trigo. Okay, integration of trigo. Okay, I will collect it from you later. Okay. Are we okay so far for the 16.1? Yes, 16.1 is actually algebra first, Okay, now I want to revise this first. Now, this is when I differentiate, right? I always only memorize one thing. I never memorize the integration one. It's just the other way around. You understand what I'm talking about? It's just the other way around, okay? Alright. Pen out your work first. Okay. Are we ready? Are we ready? Yes or no? Now, when I differentiate sine x, I get cosine x, right? When I differentiate cosine x, I get negative sine x, right? When I differentiate tangent x, I get secant square x, right? That means, hello? When I integrate cosine x, I will get sine x. Can you see it? Integrate this one, you get back this one. So what if I integrate sine x? Because there's a negative. It will be negative cosine x plus c. Everybody okay? Then if you want to integrate secant square x, you will just into what? Tangent x plus c. So I just memorize one set. I don't have to memorize two sets. You understand? You just get this correct, then you just change it around. I always write this and the formula list myself. Everybody okay? No need to memorize so many things. You can just infer. Okay, okay, So if you look at page 103, it will tell you that cosine x is sine x plus c, negative cosine x plus c, then tangent x plus c, where c is an arbitrary constant. Okay, can the reverse of the trigo. Okay, now I am going to show you example 9 first. Okay, example 9 using this one. Now, first you must know pi is a constant. What's the value of pi actually? 2.14, right? Okay. Now I integrate this integrate separately, right? So this will become pi over 2x, right? Correct. Constant when you integrate becomes constant x, right? Okay. Now sine x. So what will it be? Negative cosine x. So negative cosine x, then you just plus c. That's all. So you get a pi over 2x minus cosine x plus c. Everybody okay? Everybody okay so far? Can, Okay, next one. Now a lot of people will say, "Cham liao. Integration got no quotient rule, I don't know how to do it." Okay, I'll try to do This is the same as denominator, I just write 2 times off. Okay, now, of course, this one is the whole thing, understand? Okay, now, I want to show you here, all of you look up. This is 4/3. 1 over cosine is secant, right? 1 over cosine is secant. So this one become secant square x, correct? You don't know what? Okay, 1 over cosine is secant. What about 1 over cosine? Sorry, 1 over cosine is secant, correct? What about 1 over sine? Cosecant, right? What about 1 over tangent? Cotangent, you must know. Understand? Oh? Okay, so cosine is secant. Now, do you agree this one will cancel off? So left what? 2/3, right? Correct. Now, then I'm going to integrate. 4/3 remains now. Secant square, when you integrate, become what? Tangent, right? Then plus 2/3x plus c, right? Correct now? Yes or no? So you do it slowly, you will not make mistake. Okay? Now, then, look at the next box that is on page 104. Okay, page 104. You will have cosine ax plus b, then you have change it to differentiation. Then after that, you divide by the differential inside. Okay, I'll explain to you. It looks terrible, it looks horrible and vegetable. Not to worry. Let us take a look here. You need to memorize all this already. No more. Remember, when we differentiate, we must times the differential. So when you integrate, you must divide by the differential. Understand? Okay, what do I mean by that? Okay, can you look at this one simple one? Okay, all of you look up. Don't look at your textbook. And don't copy. Just listen. Sine, when I integrate, I'll get negative cosine 2x, right? Now, what is the differentiation of inside? 2, right? So you just divide by 2. 1 over a is just divide by a, right? Correct now. Then you plus c. Everybody clear with what I'm saying? Okay, now you look at the thing. I'm going to show you now. This is what it means. I just want to show you. Cosine ax plus b dx will be 1 over a sine ax plus b plus c. This is what it means. Okay, when you say 1 over a, you times 1 over a means you divide by a only, ma. Correct or not? I'm going to show you something. All look up. Let me do this. Let's say I have cosine 2x plus 10. Correct? When I integrate cosine, I will get sine x. So this answer will be sine 2x plus 10. Correct. When I integrate inside, it becomes what? 2, correct? Okay, now, this is 1 over 2. Now, 1 over 2 is the same as divide by 2. Then you just plus c, the constant. Just all. Understand what I'm saying? Can see now? Can see better now? Okay. Integration very easy. Just like that, you don't have a lot of things. Understand? So, remember to divide by the differential, that's all. Okay, next example. Next example. Okay. What if I do this? It will be 2, right? I integrate sine, I get negative cosine. So this one will be negative cosine. Then I must divide by 5, correct? Because when you integrate inside, it becomes 5. Then no more already, so plus c, right? So this will become negative 2/3. Can see now, right? Can see now, Okay. Then we look at part C. When I integrate secant, I will get what? Tangent 3x plus 5, right? Divide by what? 3. Divide by 3, if you don't want to write this way, is the same as times what? 1/3, right? Oh, then I plus C, that's all. Finish already. Okay, then you ask me, Joe, if I put like that, is it correct? It's still correct. Just another way of doing it. Agree, class? Okay? Alright, good. Next, last example. Last example. Class, let me just tell you this. There's no way you can integrate tangent, understand? You can only integrate secant. But there is a formula. A formula of what? Don't know whether you remember or not. Tangent square x is equals to what? Okay, maybe I should write the other way around. Secant square x is actually tangent square x plus 1. Last year you learned before. It's in the formula list. Can I not? Okay, so what about if I have tangent square x? Secant square x minus 1, right? Okay, so all of you look up. This one will become secant square alright. Because I changed this tangent now. Tangent square to secant square, this is minus 1, correct? Understand now? Understand now? Okay. So I integrate. Secant square will become what? Tangent. I must divide by what? 2, right? Then minus x plus c, right? You still must integrate this one. That's a negative 1, so it's negative x. Agree? Now, some people will say, oh, very ugly, I don't want to write this. So you just put a half here is also okay. Half of tangent 2x plus 5 pi minus x plus c. Are we okay so far? Are we okay so far? Okay, good. I do not have any questions for you to do today. There is no homework. You go back, can you please look at all these examples again? Tomorrow I'm going to continue the next example and I'm going to start homework. Everybody okay? Alright, stop the video.